In biprism experiment, light of wavelength A is used to obtain an interference pattern. Then fringe width is W1. Fringe width is light of wavelength lambda actually. Fringe width is W1 at a distance D1 from the screen. And when the screen is moved towards the biprism. When screen is moved towards the biprism, fringe width becomes W2 and distance is D2. Remember here, because the screen is moved towards the biprism, so that distance D2 is less than D1. Distance D2 is less than D1. The distance between two virtual images of the slit. Distance between two virtual images of the slit. So, as far as the bandwidth is concerned, bandwidth W1 is equal to, or W is equal to lambda capital D divided by small d. Lambda capital D divided by small d. So, W1 is equal to lambda D1 divided by small d, and W2 is equal to lambda D2 divided by small d. As here D2 is less than D1, therefore as D2 is less than D1, it means W2 is less than W1. Therefore W1 minus of W2 is equal to lambda D1 divided by small d minus lambda D2 divided by small d, or W1 minus W2 is equal to lambda by small d is taken as common, D1 minus of D2. D1 minus of D2. We want to find out distance between two virtual images, small d is equal to lambda into D1 minus D2 divided by, this term will be taken in denominator, so it is W1 minus of W2. D1 lambda D1 minus D2 upon W1 minus W2. So, out of 4 options, which option is correct? Lambda D1 minus D2, lambda D1 minus D2 upon W1 minus W2. So, option D is the correct option for this question.